Using first principles, we have to find out the derivative of fx equals to 1 plus x, 1 upon x, which is f dash x is given as limit of h tends to 0, f of x plus h minus f of x divided by h. Now, what is the value for f of x plus h? Wherever x is, you will just write x plus h. What is the value for fx? This is same, which is 1 upon x. Just substitute it here. So what you will have is limit of h tends to 0. In place of f of x plus h, you will write 1 upon x plus h. In place of fx, you will write 1 upon x divided by h. So what you will have is limit of h tends to 0, x into x plus h. So this would be x plus h divided by h, which is 1 upon h. So x and minus x will get cancelled out, h upon h will get cancelled out, and what you will have eventually is just this limit of h tends to 0, 1 upon x to x plus h. So wherever h is, we'll just put equal to 0, and this will be 1 upon x into x, which is minus 1 upon x squared. This minus is still remaining. So what you have found out is that f dash x is equal to minus 1 upon x squared. Well, just pick up example 2 here, which is supposedly in case if you have the function fx equals to x to the power n for n greater than 0. Suppose you have this and you want to find out the f dash x for this. Okay, so f dash x is equal to f of limit of h tends to 0, f of x plus h minus f of x divided by h, which is limit of h tends to 0, x plus h tends to n minus x tends to n upon h. By binomial theorem, you can write x plus h tends to n as nc0 x to the power n plus nc1 x to the power n minus 1 h, and plus so on to ncn x to the power 0 h to the power n. And in case if we ask you to find out x plus h to the power n minus x to the power n, so everything minus x to the power n. Okay, so which will be actually equal to, take up h, which is common here, because this will nc0 is just 1, so x to the power n and minus x to the power n will get cancelled out. Okay, and what will be remaining here is just this, so h will be everywhere there, so you can take up h common, and what will you get is eventually this n into x to the power n minus 1 plus so on to h to the power n minus 1. Okay, now you can substitute this x plus h to the power n minus x to the power n there, and what will you get is limit of h tends to 0. In place of x plus h to the power n minus x to the power n, you can write this, which is h limit of, it is h n into x to the power n minus 1 plus h to the power n minus 1 divided by h. I don't know, my h and n probably are not able to figure out the difference between them. Anyways, so what you will have is eventually is n into x to the power n minus 1. Okay, and then all the terms which involves h to the power n minus 1. So all of those terms will become 0, and the only term which will be remaining is this term. So it is nx to the power n minus 1. So f dash x is equal to this, nx to the power n minus 1. Okay,